Okay, so we're going to be going over problems 10 and 11 of the EE301 12-week review packet. So the acronym for capacitors and then the acronym for inductors. Eli, the Iceman, is just a memory crutch to help you figure out like how a circuit will react to inductive and capacitive elements. So these problems are kind of conjoined. It seems generous to call these acronyms since they're not acronyms. They don't actually like stand for anything like one-to-one, so to speak. Like the I doesn't stand for something specific, and the C isn't really even part of the phrase. What ICE means is that in capacitive circuits, that's what the C is for, you have current I leading voltage. So remember, voltage can be represented with a V or with an E, and that's what the E is for. Current is represented with an I. So current leads voltage, I leads E. So what does that mean? That means that when you have a capacitive circuit, either a circuit with a single capacitor or a circuit with more capacitive inductance or impedance than inductive impedance, you'll have your current angle being higher, more positive than your voltage angle. So if you remember that those curves that we had before, this being the real axis, this being the imaginary axis, we might have our current in red, and it could be, the phasor could be up here, and that would be current, and maybe our voltage would be somewhere like in green, might be somewhere like down here or something like that. So that's what that means. And it depends on the circuit, of course, how these specific curves are going to play out. But the point is that you will have a higher value, not in magnitude maybe, but in like more positive for current when the inductor, when you have a capacitive circuit. So current leads voltage in a capacitive circuit, ICE. The reverse is true in an inductive circuit. Inductors resist change in current. Therefore, in an inductive circuit, remember L is our symbol for inductors, and that means that voltage will lead current in the same way. So if you have a mostly inductive circuit, then your current angle should be more negative than your voltage angle. And that's all that means. So that is problem 10 and 11. If you need any more help on them, like explaining the acronyms, please feel free to look it up online. There's a lot of like great explanations for how this works, and it can usually be beneficial to see a graph of this. So that's all for these problems.